What role do the second life applications play in the circular economy of lithium-ion batteries?
Well, second life applications are actually the most viable and sustainable solutions for avoiding batteries to enter the recycling chain. At the end, all batteries will enter the recycling chain because batteries degrade during their useful life. But of course, if we can intercept batteries and exploit their functionalities and the residual capabilities before they enter the recycling chain, is a most viable solution. Now, either the Rematec, you can see three different strategies to implement second life. Autocraft is actually working at pack level. In this booth, you see two different alternatives for working at module level and at single cell level. These two companies are part of the BATMAS project, that is a European project funded under the I3 program, Interregional Innovation Investments Program, that I'm coordinating since 2 years, where we are trying to close the loop in the battery value chain, trying to exploit where most suitable all the possible alternatives from second life to recycling and to reintroduction of materials into the production of new batteries. That's very strategic for Europe. So the strategy that looks at reusing the module, of course, is economically attractive because you don't have to disassemble the module to reach each single cell. So it's a benefit in terms of cost. It's not always applicable. It depends on the residual capacity of the module that is intercepted. And of course, then you have to work on the electronics to make the second life product that you build compliant with the requirements of the market. If you go at the single cell level, you can then have a very in-depth knowledge about the characteristics of each individual cell. And of course, you can have more flexibility in building modules that are customized to the requirements, but definitely you have to invest more time to get there, and probably you need more automation to be competitive in the market. So every strategy has its own implications, challenges, and we are trying to address them in this project that is 1.5 years to the end. So hopefully very soon you will have these products in the stationary market.
What are the biggest technological challenges in the manufacturing of EV batteries today?
The first challenge would be to find the right cells that we could rework for many applications in Second Life. So I would say finding the cells, good cells, and testing them are the first challenge. Then transportation at acceptable cost from any part of European Union to get them to a factory or refactory. And then, of course, finding the right markets. But basically, it's very versatile. We can arrange those cells for many applications, from small stationary to propulsion of big boats or everything. There are many markets for it, and the price are still very competitive regarding the new cells we could buy on Asian markets.
Are you talking about Europe, or you can say something about French?
Part of French companies were pioneer for this because at the beginning of this new wave of EV, Renault did experiments with fleet, and that permit to have access very early to second life cells. So it's been several years we are working at finding markets for them. Now I think it's the moment to open it and show that it's very good possibility for reusing a lot of matter that is still for the moment hard to recycle from a materials point of view.
We found out the recycling of lithium is something that is really needed, but also at this point there is a difference between the offer and the demand. The prices are very high, and surprisingly enough we found out that if you look at the batteries that are supposed to be at the end of their lifetime, they are not. I mean, if you sort properly the batteries, our experience is that 80% of the batteries that reach our plant as, let's say, spent batteries are not spent batteries. 80%, they still have 90% state of health. What is state of health? It means that 90% of the cycles they still can do, charging, discharging, so you can make use of them for a different application. What kind of application we come up with? This wonderful 5.5 kilowatt hour power bank that is useful for all kinds of applications. For instance, if you're at home, you have a solar plant, you connect this device, and at night, when the electricity rate goes up, you don't have to pay the high price because you have stored the electricity during the day. It's difficult to sort and to select because you get so many batteries and that you have to do a proper sorting, a proper selection, and that takes a bit of time. To encapsulate again the batteries, we have to, of course, measure the state of health.
How do current European regulations support or hinder the development of a strong battery remanufacturing industry?
Well, we all know that the battery regulation is being published. It will be applied in Europe for certain battery categories starting February 2027, so it's a couple of years from now. What the battery regulation contains? Well, there are various aspects that are extremely innovative to foster remanufacturing and in general second life applications. Probably the most innovative aspect is the battery passport, the so-called digital battery passport. And in the regulation you have all the set of information that the digital battery passport should contain in the future. Why is this battery passport interesting for the second life? Well, because you can have interesting information about the nominal capabilities of the nominal features of the battery, and then you can apply tests targeted to the specific type of batteries you intercept, for example. Also, the battery passport will contain rough information about disassembly plans that should be implemented once the battery reaches the post-use phase. So the dismantler or the disassembler can actually exploit this information to make disassembly more efficient. The big change to this industry will happen when battery packs will be already designed to think about the second life or the post-use applications. This is not there yet, but I think will be coming soon. The other big innovation for the circular solutions in batteries contained in the battery regulation are related, for the first time ever, to minimum recyclate values for different materials that should contain the batteries. Of course, this does not directly affect remanufacturing, but affects the circularity of the battery sector. And of course, these targets are low in the first years of implementation of the regulation, but will increase in next year. So overall, this package, I think, really boosts the development of a circular battery valley in Europe.